velocity time graph and the acceleration. Velocity time graph is a very useful tool for getting the information about the behavior of the motion of a body which has some velocity in certain instant of time. From the velocity time graph, as we see in the figure, if the body is moving in such a way that throughout the time it has a constant velocity, then, for example, the velocity is 30 meter per second. Then the velocity time graph throughout the time, throughout the course of motion will remain uniform, will remain a constant line. The velocity time graph for the complete course of motion will be a straight line parallel to the x-axis or the time axis. And the yellow shaded area you can see can be calculated by v cross t, which is actually the relationship of the distance. So it means that area of the velocity time graph will provide the information about the total distance traveled by that body. As we know that the distance can be calculated, means s is equal to v cross t. As we know that velocity or the speed is equal to distance over time. So from that relationship we can get that the distance is equal to speed into time. So the distance traveled will always be equal to the area obtained from the velocity time graph or area under the curve of the velocity time graph. As we see, the yellow portion or the yellow shaded area is equal to 30 cross 6 width into height. Area is always equal to width into height. Width is 6 and height is 30. So total distance traveled by the body in 6 seconds with a speed of 30 meters per second will be equal to 180 meters. We will move further to the next slide. If the body is not moving with a constant velocity or the uniform velocity and the body is moving with some changing velocity, and the behavior of the change of the velocity is according to this curve. And you can see that in the first 20 seconds, the body is uniformly increasing its velocity. It means that it has uniform acceleration. And that acceleration is, or the increase of velocity is 10 in 10 seconds. It means it is the body is increasing its velocity or has a uniform acceleration of value 1. And in the 20 to 40 seconds, the body is moving with a constant speed. And from the time 40 to 50 seconds, the body is decelerating or decreasing its speed. And then from 50 seconds to onward, the body is increasing its speed exponentially, or it has some variable acceleration. So in the first phase, the blue portion of the line, the body is accelerating with uniform acceleration. And in the second phase, or the red line, represents the constant velocity or the zero acceleration, no change in velocity. And in the third portion, or the green line, the body is moving with decreasing velocity or negative acceleration. And in the last portion of the line, from 50 seconds to onward, the body is increasing against its velocity, but not uniformly, and it is increasing its velocity exponentially. So, if the velocity time graph of the body is given, then we can predict or we can understand the behavior of the movement or the motion of the body throughout the time. And we can calculate the distance traveled by that body in that course of motion the duration of time by taking or calculating area under the curve of this velocity time graph. Next, we have to consider the slope for graphical interpretation of the acceleration. So what is the slope? As shown here, slope of a line. So first we go back to this slide. What is a slope? Slope is actually the ratio of perpendicular to the base. Our vertical axis change to the horizontal axis change. Our dependent variable change to the independent variable change. We can define different ways. Slope is a ratio of perpendicular over base in a right angle triangle. If we form a right angle triangle, then we say that the slope of the hypotenuse is the ratio perpendicular to the base, and it is also known as tan of theta. And for any line, just like shown in figure, we can get the slope by taking the ratio of perpendicular to the base, and this slope is also equal to tan of theta of this line. If theta of the line is given, then we can say that slope is given by taking the tangent of that angle. We can calculate the slope, and in an alternative way, we can calculate the slope by taking the ratio of perpendicular to the base. Now, for the specific case of acceleration, for the graphical interpretation of acceleration, we use the slope. Average acceleration is a slope of the line connecting the initial and the final velocities. It means if we are given with the velocity time graph and want to find the average acceleration between the 2 points or 2 instant of time, what is the average acceleration? We can calculate that average acceleration by calculating the slope of the line joining the 2 points, blue line. And slope can be calculated by using this formula, delta V over delta T. Delta V over delta T. But for a certain instant of time, not the average acceleration, if you want to calculate the instantaneous acceleration, the tangent to that point, for example, if we have a point A on which we want to calculate the slope of the line, or want to calculate the instantaneous acceleration, how much acceleration or how much ability to change the velocity at that point. If you want to calculate the ability of a body to change its velocity, or if you want to calculate the instantaneous acceleration at point A, we have to take the tangent to this point to this curve. We have to take the tangent at this point to this curve, and the slope of tangent, means red line, will give the acceleration, instantaneous acceleration. The slope, how we will calculate the slope? By taking the ratio perpendicular to the base. So to calculate the instantaneous acceleration, we have to use the tangent, and the slope of the tangent describes the instantaneous acceleration at certain point. And another important aspect, and the last aspect of the acceleration, very important aspect, that not only the change in magnitude of the velocity changes the acceleration or produce acceleration. Acceleration is actually the change in velocity. We know that the change in velocity is known as acceleration, but change in velocity may happen or may occur because of two reasons. Number one, velocity may change due to its magnitude change. And number two, the velocity of a body may change due to its direction. In this slide, we will discuss the change in velocity due to direction. A change in velocity is known as acceleration. So, acceleration due to change in direction. For example, if a body claims that I am moving with a speed of 2 meters per second, and initially from the start, it covers a distance of 2 meters in 1 second. So, he claims I have a velocity of 2 meters per second. And then in the next second, he claims I again traveled 2 meters in 1 second. So, I am moving with a velocity of 2 meters per second. And for the whole course of motion, he claims I am moving with a velocity of 2 meters per second. Then we will say that, no, you are wrong. As you have changed the direction, so you are not displacing from the initial at the start point with that much velocity of 2 meters per second, as in 2 seconds you will displace or you will shift from start point to the final point. In 2 seconds you will shift toward displacement of 4 meters, but as you have changed the direction, your total displacement, how much displaced, how from your initial place to the final place, how much you are displaced now, not 4 meters, it is less than 4 meters. As in a triangle, hypotenuse is always, magnitude of hypotenuse is less than the magnitude, sum of the magnitudes of the base are perpendicular. So these two sides, the sum of these two sides will be more than the length of or magnitude of this side. It means body has reduced its displacement because of shifting its direction, changing its direction. The magnitude of the displacement or the velocity will change. Net velocity will not be the 2 meters per second. I assume that this distance is 3 meters, then in 2 seconds actually he has displaced 1.5 meters per second. So it means actually he was claiming that the person claims that I'm moving with the velocity of 2 meters per second, but actually his velocity is 1.5 meters per second. So how much is the change in velocity? Actually, there is a 0.5 meter per second change in velocity. So acceleration in 2 seconds will be a 0.5 meter per second, 0.25 meter per second. Thank you for watching the video. Please visit the website www.calculator.com.